Hi, this is a lecture on logicalisation, which is a difficult topic for most students. It assumes that you have done your logical cross-reference and got an entity to and data store relationship, so there's a one-to-one relationship between entities and data stores. First of all, you take your level 2 DFD. And this is a typical level 2 DFD, which is a sales system, and it's a physical DFD, and we need to logicalise it. So we take the first step, which is to logicalise the flows by first rubbing the existing name out and replacing it with the name of the corresponding entity. And this is what happens. So we have the order entity on this data flow, customer on this data flow, order on these two data flows, and order on these three data flows, customer on that data flow. So it's a very simple task. Just replace the name on the data flow with the name of the entity that they're working with. Following that, you logicalise the stores by placing your logical data stores from your cross-reference logical around the boundary of your system. And this is what happens here. So we have the order data store and the customer data store moved to outside the boundary of the level 2 physical that you're working with. Now you rub out the existing physical data stores, leaving dangling data flows, and this results in this diagram. So we have a data store removed here, a data store removed here, and this leaves these dangling data flows, this one, this one, this one, etc. Next thing we do is to join up the dangling data flows to their relevant logical data store. This should be easy if you've logicalized your flows. The flow will now have an entity name on it and link it with the logical data store, which has the same entity name in it, and results in this diagram. So here the customer comes up there to the customer data store and back down there to 2.4. This order comes into the order data store, and that's a completed task. So you've removed the logical data stores from within the boundary to outside the boundary. Now cut the flows going between function boxes. This means between all boxes. Boxes with flows between them within the boundary, and boxes with flows between them where one box is inside the boundary and the other is outside the boundary, i.e. another department. So this is what happens here. We have cut the flow between stock records and 2.2. That's cut there. We've cut the flow between 2.4 and 2.1, and we've cut the flow between the warehouse and 2.1. And so next stage we go to is link up the new dangling data flows and join them up to the corresponding logical data store, as you did a couple of steps earlier, and this results in this diagram. So the this was cut, this data flow, and we took the stock records down to the order data store and moved it back up to file outstanding order. And here we've got this data flow was cut here between 2.4 and 2.1, so it moves to the order data store and goes back out to write out dispatch note. The next step is to rub out those boxes outside the boundary, i.e. the other departments, as you'll deal with that part of the story on their level 2 logical DFDs when you come to do them. Rub out also any flows between those boxes outside your boundary and any logical data stores. This results in the stock control box being rubbed out, and also the warehouse being rubbed out, and also their flows from them and to them, and that results in this diagram. The next step is, well, you've broken the back of the problem now and you're on the home straight, but now you have to start to do a little bit of thinking. Look at the descriptions of the functions and remove all physical considerations. Rewrite the function name, concentrating on what the function is doing, not explaining how it does it. E.g., type copy of voucher will become producer voucher. We don't care how it is produced, we just need to know what it's doing. If you're going to send the voucher to the customer, you don't care how you get it to the customer, whether it's by snail mail, email or carrier pigeon. It's not relevant, it just needs to know that that is what you are doing. So it's moving from the how to the what. Now consider each function in turn and ask, what is this function logically doing? Ask yourself, what is this function doing to the data? And you can process data in 4 ways. First, is it creating data, the function? Inputting customer and booking details, etc. for the first time when a new customer makes a booking? Is it reading data when you check to see if the course has places left to sell? Is it modifying or updating data when you alter the status of booking or guest when a cancellation is made? And is it deleting or archiving data to free up space on the disk storage so that we can take more bookings in the future? Disk storage is not a problem these days, and it's more likely that if you delete data you will lose history, and I'll come on to that in a moment. Be careful about deleting. Consider, do you really want to delete, leaving yourself with no record of what you've been doing? Or rather, do you wish to alter the status of an entity? This will enable you to go back and check stuff if a customer makes a complaint, or if the taxman is after you, or if the VAT inspector is on your back. Remove functions which just read data from logical data stores and put it back in without modifying it in any way. Function 2.2 is a candidate for this. Note also that this function is not interacting with any external entity which might have given it a reason to update the data. So remove it. And we'll just go back now to the previous diagram. And here 2.2 is the process under consideration, and it's taking information from the order data store, goes into file outstanding order and puts it back into the same data store unaltered. So you can remove that like this. And now it's gone from here. Next stage is function 2.1 is also redundant. It was necessary under the old physical system, but now logically it is not adding anything to the system. It is simply reading dispatch instructions from the logical data store and then adding them back to the same logical data store. So remove it. And we've removed it together with its flows. We'll just look at what it was like. It was there. It read the order, wrote out the dispatch note and put the stuff and put the information back in the order unchanged. So it's not adding anything to the sum total of knowledge, so remove that. And there it is removed. And you notice how the DFD has shrunk, it's getting simpler, and this is a natural consequence of logicalisation. You now need to do all the previous steps in the same way with the 2 other level 2 physical DFDs, or however many you've got, and make them into level 2 logical DFDs. Now, once you've done that, you've logicalized all the level 2 physical DFDs, you've got to make your level 1 logical DFD. Place all your logical data stores down the middle of a clean page. Take the functions you have left on your level 2 logical DFDs and place them around the logical data stores, linking them up appropriately with their correct logical data stores and the external entities they are linked to. Remove any duplicate functions. You will have duplicate booking functions in both the booking office and the hostel desk. The logic of the functions is the same, so they should be merged to form one logical function at level 2. And that's it. You've done it.